Hi, I'm Alan Ross. I'm here at the IEEE PES T&D, that's a lot of acronyms, conference. This is the 2020 version that is actually being held in 2022. These interviews that we're conducting is with thought leaders on the future of the power industry. So enjoy. Our next guest is someone that I have been around for a while now, but you know what? I've met him for the first time today. Doug Houseman, it's really good to meet you.
Good to see you.
Doug is one of the gurus of IEEE PES. He really is a blessing to the organization and also one of the wisest men with a lot of great understanding about where we've been, where we are, and where we're going in the industry. So the first question I got for you, Doug, is where are we going? What are the challenges that we're facing?
Well, I think if we're not careful, we're going to a worldwide permanent blackout.
Okay, well, that's a bad thing.
It absolutely is. If we're careful and we do the engineering correctly,
okay,
we're going to a world that will be, to a large extent, carbon-free for energy. But we've got all these people who want to wave magic fairy dust out there, turn off all of our existing power plants, and magically make us all solar and wind, and they think that electricity will be free.
That's what I love about you. It ain't going to happen. Is that what you're telling me? It's not going to happen to it?
We just don't have enough unicorns and purple fairy dust to get there. So it's going to take real engineering and real thinking. You know, one of the major topics here this week has been utilities running from vendor to vendor saying, what's your lead time on X?
Right.
2 years ago, the lead times were 8, 12, 16 weeks. Now we're talking 30, 60, 90 months.
Wow. Wow.
One of the big problems I found out yesterday is we don't make transformer steel in North America.
Right. The grain-oriented steel.
All of our transformer plants are shut down because we can't get it, so we can't make transformers, so nobody can give us a lead time.
Oh, yeah.
So that's one of the issues that we're dealing with. Another one is nobody understands that when you plug in an electric vehicle, it has two impacts. The first is it raises the demand, the kW that particular household wants, and the second is it wants kWh. Well, solar will make a lot of kWh during the daytime, but where's the car during the daytime?
Yeah.
It's off, at work or someplace else. Solar doesn't make very much kW at night. There's been a recent article on moon cells. Yeah, I make a kW in the daytime, I make 6 watts on that same solar at night.
And only when the moon's full.
Well, no, that's pretty much the average. I think you can get all the way up to 12 or 18 watts on a full moon. But, you're not even going to be able to light an LED light bulb in the kitchen on what your solar system will make at nighttime.
Right.
So we got to deal with the fact that we're going to push 5-6 times the amount of electricity out of a distribution circuit during the daytime and have to put it somewhere.
Yeah.
And then at night, we've got to bring 5 or 6 times the kW back down that circuit. We make the circuit hot during the day, even during the winter. We keep it hot at night. The infrastructure today is designed to cool off at night so that we can actually run it above its actual design nameplate.
Yeah.
A lot of our circuits are 110, 130% of nameplate during summer days. Now we're going to do it year round.
And that's going to, because one of the things we've heard here is that, say, the demand curve for power in North America has been pretty much flat for the last decade. And we've heard different people say the predictions are in the next decade it's going to go up 30%. Another one said it's going to go up 100%. Both of those were based on about a 30% EV adoption into the marketplace.
Yeah.
What do you see of that?
You look at Ford, 80% EVs by 2028 is their goal.
Right.
You look at GM, 70% by 2027 is their goal. Stellantis' announcements this week, Chrysler, Plymouth, etc., is that they want to have all of their pickup trucks, with exception of a very small percentage, by 2026 be electric. Pickup trucks are 30% of the cars on the road. There's your 30% right there in pickup trucks by 2030.
Yeah.
We're looking at a 2.5 to a 4 times increase in the amount of power going through a circuit at the distribution level. I don't care so much about transmission.
Right.
But the distribution circuits, many of which were built in the 1920s and the 1930s, and we decided to overload them when air conditioning came along rather than rebuild them because it was too expensive, now don't have the room to take electric vehicles. I've got 24,000 real circuits in a database. We do bottoms up what if. I have 300 people on a circuit, 30 of them are in the right demographic to take electric vehicles. The chargers look like this. The diversity of that charging over the time period of the day looks like this. What's the impact? And the answer is, it ain't fun.
Yeah, yeah. So you're here, and a lot of people respect your perspective, and you're kind of, you've been sounding the alarm. What are we doing about it? Okay, I know you do a lot of consulting. You're a lot out there telling people, here's the problem, and now here's the answer. So what are we doing about all of these problems?
Well, the bipartisan infrastructure bill is spending $9 to add load to $1 to make more capacity.
Right.
So the first thing we're doing is we're making it easier to add load and cheaper.
Okay.
Which is the opposite of what we probably need to do. The second thing is we're trying to keep the electricity costs down, so our state regulatory commissions in the United States are saying, no, you can't spend that much capital. And then we get to the issue of we're not creating enough engineers who can work in the industry to work our problems.
Yeah.
You know, we've gone from 9 power engineering programs in the 1990s because everybody in the 1980s said, well, we're going to turn our electrical department into a computing department, and we only had 9. We're back up to 20. But we really need to get back to that 60 or 70 power engineering programs in the United States we used to have. We turn out about 30% of the power engineers we need. You want a job out of college, even if you've got low Ds? Come out with a power engineering degree. I'm serious.
Even a D gets a job,
Yeah.
right? Yeah, and a degree, right? That's right. So with all of these huge problems that we got, it seems like the nature of how the U.S. grid structure is, it's almost as if it's like don't communicate with each other, don't solve problems together, whereas a lot of other countries have a unified approach to power. Right?
Well, they also typically have a state-owned utility, like France or other countries, and so their whole country, their whole policy is a move in that direction. You look at Australia, they have separate utilities and they disaggregated as part of their going to a wholesale market and a market operator. And so now you got everybody doing all sorts of things. Power prices during the spring were negative $40, $60, $80 a megawatt hour. Now that they're starting to get into the late end of their fall, in the evening, power prices are $1,500, $2,000, $3,500 a megawatt hour because they've gone to a large amount of variable renewables with almost no storage.
Wow, okay. And are there, in your perspective, are there major advances, not talking about Elon Musk, who's a great marketer, brilliant man, but a great marketer. Are there major or potential advances in storage? Because if we're going to go to so many renewables, wind, solar, you're going to have to store power for a longer period of time than we're doing it now, because we got storage that's very short term. Is there anything on the horizon that might help that?
Well, there's some things on the horizon. If you go down to Sandia, they're working on almost 100 different battery chemistries. But I don't think batteries are going to get us there. I think it's going to be pumped hydro, good old pumped hydro. But we got to do it differently. So let's go half a mile offshore to an area where the land underneath the ocean is very close to the surface, and build the upper reservoir right out there in the ocean pump seawater in, pump seawater out. And we've got so many dead zones around so many countries that doing that's not going to have an impact on the life in the sea anymore. And it may actually bring life back into that area. But there's an area off Corpus Christi, Texas, where we could easily put a 30 gigawatt by 100 terawatt hour storage system. If it had been there in February of 21, there wouldn't have been any rolling blackouts. There wouldn't have been $9,000 megawatt hour prices. None of that would have happened.
With that one storage facility off
At
the
that
coast of
size,
Florida.
yes. They were short 12.4 gigawatts. That would have been a 30 gigawatt facility, so more than 3 times what they were short.
Yeah.
And with the amount of storage, they would have ridden through that 122-hour period without a problem.
Okay. Now, is that close to happening, or is
No,
it? No.
it's-
Okay. Is that
It's
regulatory?
on Doug's fantasy board.
Okay. Well, good. You've got some great ideas about what we ought to be working on. From a consulting perspective, you do a lot of work with both utilities, with manufacturers, producers, things like that. What are you working on right now that's the most exciting to you, that you think might be one of the solutions to the problem?
I think the most exciting thing I'm doing is I'm helping 5 utilities bring their labs back.
They're testing labs?
They're laboratories
Okay.
to understand what EV chargers do, what insulation does,
Okay.
what kinds of transformers they can use, how can they use solid state and things like that, because we really got down to 2 labs in North America. There's IRAC up at Hydro-Quebec, which isn't what it was 20 years ago when they had almost 2,000 people working there full time. They've finished a lot of the work that they were trying to do to understand things, and so as people have retired, they mostly haven't replaced them. And then there's Dolan Labs down at AEP, which does everything from transmission to household. But their staff is probably about a dozen people in these days. So we really haven't had a testing organization in North America to understand people's behavior and things like that. Next Energy in Detroit has an all DC house that you can live in for a week, and they monitor everything that goes on in that house to see what's going up and what's going down and how people live. But that's one house.
Well, yeah, right. It's not going to change the world.
No.
No. You do global work, obviously. You know a lot of what's going on. What country is doing it, in your opinion, not, let's just say better than others?
I think the one that's learning the most is Australia because of the chaos.
Okay.
I think the one that's thinking about it the most and most deliberate is probably Sweden.
Really?
They've got a lot more people and a lot more disciplines involved in thermal storage, in energy conservation and improvement in insulation, and a lot of other industrial products.
Yeah.
That change the amount of energy that's required rather than just looking at how do I make more.
Well,
I'm not going to say Sweden is the best or the most advanced, but I sure do like their approach. If I don't have to use it, I don't have to make it, I don't have to transport it.
that's good. Yeah, it's a different approach. So I want to switch gears a little bit. IEEE. You are an IEEE stalwart. I don't go to meetings or do anything that I don't see Doug. I know you were one of I'm on the Smart Grid Committee. We do some work on that there, and you were there at the beginning. Talk about the value of IEEE to that engineer. We're not making enough of them, and not enough of them are getting involved with IEEE as we'd like.
You know, if you look at the technical committees, and I'll start there.
Okay.
They have working groups that typically have 15 to 20 of the top engineers in the world and the scientists on that particular topic. If you're a transformer engineer in a utility and you're not on one of the transformer working groups, you're not getting the kind of education that you should get, because sitting in a 2-hour working group meeting is like sitting through a whole semester of college class on transformers. You move from there to shows like this. This is the best place in the world to find new vendors, new innovations, other things like that, and to build a network and those personal relationships to hopefully get the part you need to fix something overnighted to you rather than it's a 6-week or an 8-week lead because somebody that you met from some company is willing to go back in the warehouse and see if they've got one that's not on the inventory.
Right.
The other thing is you meet other engineers from other utilities and you have a chance to actually have a real conversation and talk about lessons learned where it's completely off the books.
Right.
And so you can have that kind of frank discussion about a piece of equipment, about a manufacturer, about a particular configuration, about root cause analysis, and those sorts of things where it's private, off the books, and nothing you say, nothing they say ever goes anywhere else because it's a fraternity.
Yeah. There's, somebody asked me, why does IEEE take so long to develop a standard or to update a standard? And my answer is collaboration takes time.
Well, it's not just collaboration, but as you're building that standard, you typically want to know that it's going to work in a lot of situations.
Right.
And if you don't have people who are involved from some of those situations, then you've got to reach out and find somebody who's willing to look at what you're doing.
Right.
We try to get big ballot groups on standards because we're trying to get as big a diversity of opinions and experience as we can.
Right.
I'm only work on 1 or 2 standards at a time, but I probably ballot 12 or 14 a year, and I spend 3 or 4 days of my free time, which means it's typically 3 or 4 weeks.
Yeah.
Going through that standard carefully and thinking about situations where I'd be using that standard, and is there anything that's going to break that standard? And being involved means you get to bring your situations into the discussion. You make the standards go faster. Yes, there are disagreements. They're important disagreements because they're typically technical. People aren't going to get personal on a standards committee. They're going to get technical.
Right.
And yes, some manufacturers want to do A and others want to do B. And you can tell when you couldn't come to consensus because you go through the standard and it's option A or option B or option A, B, C or option C, D, E, F or whatever. And that's typically because the manufacturers do things differently. And we didn't have enough horsepower from the utility industry to drive those options to closure.
Yeah. Notice I have a rock song that plays in my phone, Stairway to Heaven. So one of the things you've got to help us do in the power industry is make sure we keep the lights on, make sure people hear what you're saying, and make sure people apply to it. But our guest has been Doug Houseman, who I love sitting down with you because I can't ask you a question when we're on these committees that I don't know the answer you're going to give, but I always love the answers you give, my friend. But thank you so much for joining us, and we appreciate it. Thank you for being part of IEEE and all that you do for PES. Well, encourage young engineers to join.
Well, I always do.
Yeah.
I got our company to join as a corporate member so that Burns & McDonnell is now a corporate member of IEEE PES, and our goal is to get at least half of our engineers to be members of PES, and given that we've only got 55% of our engineers who are electrical,
yeah,
that's a pretty good goal.
That is a pretty good goal. Why they have not been a member of IEEE?
Some people aren't, especially the young engineers, because they come out of college.
Yeah.
They were student members.
Yeah.
They don't see any value in staying members, and so that's something we've got to do is build more value for the engineers in the early end of their career.
Same is true of power engineers that go to work for utilities. There's not enough of them, as you said, but we need more of them who then become part of, they're the practitioners, both the Burns & McDonnell side and then the utility side of it. But anyway, thank you so much for what you do. Thank you for joining us today, Doug.
Thank you for having me.